Picture this. You've got a massive steel container, and it's filled with a highly volatile, potentially explosive chemical. It has to cross an ocean, move by rail, and then ride on a truck, taking weeks to reach its final destination. So here's the question. How do you actually safely monitor that dangerous cargo across such a complex global journey? Well, welcome to this explainer. I'm absolutely thrilled to walk you through a massive shift that's happening in global logistics right under our noses. We are looking at the digital transformation of the ISO tank container. Now, for decades, these were essentially just passive, high-grade stainless steel pressure vessels. But today, we're exploring how they're evolving from isolated, rust-prone metal cylinders into connected, highly intelligent robotic assets. It's really fascinating stuff. Okay, let's dive into this. Here is our evolutionary map for today. First, we'll look at the manual era's blind spots. Second, building the smart tank. Third, AI, the proactive safety net. And finally, why this transformation matters. Basically, we're moving straight from physical clipboards to invisible cloud computing. All right, Section 1, the manual era's blind spots, working in the dark. To really appreciate how far this tech has come, we need to set our historical baseline. Operating an ISO tank used to mean relying entirely on labor-intensive, reactive, manual inspections at every single node of the supply chain. Just look at this stark contrast. In the analog era, operations relied heavily on paper manifests, reading analog dials stuck in thermowells, and honestly, just a lot of manual guessing games. Today, those outdated methods create severe financial and logistical blind spots. We're talking expensive demurrage charges, which are basically massive penalties for delayed cargo, endless idle depot time, and missed vessel connections that can completely derail a modern, fast-paced supply chain. But it wasn't just about the money. There was a heavy human toll and a very real physical danger here. Manual checks meant personnel literally had to climb top walkways just to perform routine pressure checks. Checking those rear pressure gauges or reading dial thermometers meant exposing workers directly to chemical vapors. Plus, there was a super high slip and fall hazard risk. It was dangerous, everyday work, all just to get a simple analog reading. And, cargo quality suffered immensely too. During the heating processes at depots, operators had to manually regulate steam valves. They'd check heating line pressures with local gauges and measure skin temperatures with handheld temperature guns. Without continuous thermal feedback, this manual supervision naturally led to constant over- or underheating, which often just ruined valuable liquid cargo. It was a severely inefficient way to operate. Which brings us to Section 2, building the smart tank. Hardware meets hazardous cargo. So how do we fix the blind spots of the past? Well, we bring in the IoT hardware revolution. We're talking about turning these, quite frankly, dumb steel cylinders into real-time data transmitters. But here's the catch. You can't just slap a standard smartphone or basic sensor onto a chemical tank. This equipment absolutely must be ATEX-certified. As defined here, ATEX-certified means specialized equipment engineered to operate safely in explosive or hazardous environments, specifically HAZLOC or Zone 1 and 21, without causing a single spark. The technology has to be uniquely and rigorously engineered to survive extreme transport conditions and volatile vapors. No cutting corners here. Let's move on and see how this builds. Here is the brilliant modular IoT tech stack that makes a smart tank possible completely without ever breaching the cargo seals. Step 1, GPS and GSM telematics terminals. These continuously broadcast exact global positioning and route data. Step 2, non-intrusive temperature sensors. These are mounted right on the shell or within thermowells for high-precision, continuous readings. Step 3, digital internal pressure transmitters. These monitor the ullage space, that's the empty pocket of gas above the liquid, for any unexpected vapor buildups. And Step 4, heating system wireless sensors, attached directly to steam channels to enable over-the-air thermal management. It's a total game changer. Now, what's really interesting to me is the addition of 3-axis shock and impact detection. By utilizing accelerometers, operators can log the exact moments of physical damage. So whether it's a harsh drop by a crane handler or a violent bump during road transport, the mystery of transit damage is completely eliminated. They know exactly when, where, and how an impact occurred. No more guessing games. All right, let's move into Section 3, AI, the proactive safety net, thinking beyond the data.
So we have the physical hardware in place, but collecting mountains of data isn't enough without a software brain to actually process it, right? By connecting this IoT hardware to the cloud, artificial intelligence shifts operations from reactive logging to proactive management. This creates a really smart system of management by exception. Instead of dispatchers and maintenance teams staring at thousands of meaningless data points on a screen, they only receive alerts when cargo parameters actually drift outside predefined safe thresholds. The AI brilliantly prevents dashboard fatigue and keeps the operational focus exactly where it needs to be, on what requires immediate attention.
And here is where it gets incredibly dramatic. Take a look at that metric, X degrees Celsius per hour. Certain sensitive chemicals can actually self-polymerize or decompose if they're exposed to excessive heat, so the AI continuously analyzes live temperature gradients. If it detects a subtle exothermic microtrend, a minute rise in heat represented by this specific formula, it instantly triggers an alert. This means AI can stop sensitive chemicals from self-polymerizing hours before a dangerous runaway reaction or a catastrophic explosion even happens. It is literally life-saving technology. And this beautifully illustrates AI's power to optimize even the most complex, mundane tasks, like thawing solidified cargo. AI predictive optimization calculates the exact steam or electrical heating time required. It factors in outside ambient weather and the specific product's viscosity. This proactive calculation prevents the cargo from scorching, drastically cuts depot energy costs, and optimizes yard turnarounds and empty repositioning to maximize overall fleet utilization. It's optimization at its absolute finest. Finally, Section 4, Why this transformation matters, the real-world impact. Let's bring this narrative back to the industry as a whole and look at the practical outcomes. So the crucial point is how this complete operational redesign impacts every major player in the supply chain. For shippers and consignees, the smart tank guarantees complete end-to-end cargo integrity with verified digital logs. For tank operators and maintenance and repair managers, it completely eliminates manual reporting costs, reduces claims from damaged goods, and prevents catastrophic equipment failure. And for depot personnel, it automates cargo heating and completely eliminates the need for those dangerous physical topside inspections we talked about earlier, massively enhancing site safety. To summarize our core thesis for this explainer, real-time data turns global tank container logistics into a transparent, safe, and highly efficient network. Replacing analog thermowells, manual steam valves, and paper logs with ATEX-certified IoT telematics and artificial intelligence, well, it isn't just a basic technical upgrade. It is a fundamental, industry-wide leap forward that redefines how chemicals and liquids are moved around the planet. Which leaves us with this final, fascinating question. If a simple, passive steel container can become this incredibly intelligent, what part of the global supply chain will wake up next? Thank you so much for joining me for this explainer. Keep questioning, keep learning, and I'll see you next time.